And then I will just
All right, hello everyone, welcome to our 2023 awards ceremony. So we're not going to start just yet. We're going to take just a few minutes to let everyone join. So please go ahead and pin our video to your screen so you can see us, and just go ahead and take a few minutes to relax, and we're going to get started.
Okay, we're just going to wait until about 3:05 to start, just so everyone can join. So thank you guys for your patience.
Hello everyone, and welcome to our 2023 Math Invitational for Girls. This is our 9th annual event, and we're so excited to see you all here. And we have had an amazing year putting this together for everyone, and we are so excited that you guys are here, and we hope you enjoy our award ceremony and enjoyed our competition. But first of all, we want to introduce everyone on the team. I will start with myself. My name is Marissa Liu, and I am a senior at Colorado High School, which is in Memphis, Tennessee. And then I will also introduce one of the team members that could not join, unfortunately, and her name is Cindy Kong, and she is also a senior. She goes to Houston High School in Memphis, Tennessee.
Hi, everybody. My name is Ira Sharma. I'm a junior here in Memphis, Tennessee at White Station High School.
Hello, everyone. My name is Jerry Shao. I'm also a junior, and I go to Memphis University School.
Hi, everyone. My name is Annie Wu, and I'm a sophomore at White Station High School.
Hi, my name is Emily Zhang, and I'm a sophomore at White Station High School.
Hi everyone, my name is Raika Chopra and I'm a freshman at Mission San Jose High School in Fremont, California.
So this is our competition schedule. So we already introduced the MIG team. And then next we're going to have two guest speakers. Dr. Margaret Callahan is first. And then for the second speaker, we have a quizzes game. And then the second guest speaker is Professor Ashley Weaver. And then lastly, we'll have the award ceremony and closing remarks.
So before we move on, I want to show you all the participant statistics. This year we had 89 contestants from 66 schools in 18 states. And we're so thankful that there are so many schools and so many participants that participated in the MIAG this year. Next, I'll hand it off to Annie.
Just to get a little bit of a survey of who's here with us today at the award ceremony, can y'all go ahead and type in the chat what state you're calling in from? We'd love to know because we've had so many states represented this year. We just want to compare what it was like last year compared to what it was this year. So go ahead and drop in the chat. Next, I'm going to be passing it off to Annie, who's going to introduce our first guest speaker.
Okay, so I would like to welcome our first guest speaker, Dr. Margaret Callahan. So a little bit about her. Dr. Margaret Callahan is a mathematician working at the U.S. Department of State's Bureau of Conflict and Stabilization Operations in the Office of Advanced Analytics, also known as CSOAA. Margaret started at the State Department in October 2018 as an AAAS Science and Technology Policy Fellow before converting to the civil service. In CSOAA, Margaret leads a team of 6 conflict analysts who use data and a range of quantitative methods to understand conflict dynamics and inform U.S. policy and decision-making. Prior to joining State, Margaret was a visiting assistant professor at Emory University's Math Department and an AAAS fellow on Capitol Hill, where she worked for a U.S. Senator on education and workforce development policy. Margaret earned her PhD in applied mathematics from Case Western Reserve University in 2016. Her academic research focused on Bayesian statistical inverse problems. Although no longer teaching, Margaret is passionate about math education. She was a volunteer instructor with Emory Math Circle, a mathematics enrichment program for local youth, and served as a math and science education volunteer in Peace Corps, Kenya, from 2009 to 2011. Please join me in welcoming Dr. Margaret Callahan.
Thank you so much for the introduction. I think I can share my screen. Let's see here. Okay. Can everyone let me know if you can see the screen?
Yes, we can see it.
Okay, thank you so much. Thank you so much for the introduction. I'm going to, I'll leave my video on for the moment. My internet at home is not great, so I may turn it off as I present. But for the introduction portion, the introduction mentioned, but my name is Margaret Callahan, and I'm a mathematician working for the federal government in Washington, D.C. I'm really honored to be here to speak with you all. I just want to thank the organizers of this event for inviting me to speak. It's truly the best part of my Sunday, so thank you so much. I have had kind of an unusual career in mathematics, and I think might be interesting to folks interested in math currently and maybe in the future. So I'll tell you a little bit about my path. So I'm going to shut off my video to protect my bandwidth, but to get things started. Usually when we see people who have PhDs in math, you assume that they've always been good at it or always have loved it. And for me, that was not the case. So I went to high school at Hawken which is a suburb of Cleveland, Ohio. And I think I saw some Ohio folks are joining us today, which is great. And up until my senior year, I didn't like math at all. I hated it. I thought it was very difficult and boring, and it didn't seem like any of my professors expected me to feel differently. None of my teachers really took the time to show me any of the cool things you could do with math or explain how beautiful it can be. During my senior year of high school, I had a math teacher, a woman, who changed everything for me. She encouraged me, she helped me to see that I could do math, and she demonstrated its beauty, including through math-related art projects. I remember making beaded necklaces where the colors of the beads represented the digits of pi. And so when I went to college, I went to Union College in upstate New York. So this is a little illustration of my rambling journey. I knew I wanted to study math in college. And even though I loved it when I went to college, I still found it really difficult. And it was always my most challenging subject in college. But I loved solving problems. So I worked hard and I learned everything I could. And when I graduated from college with a math major and a classics minor, so I had been studying math and Latin, I did not know what I wanted to do with my life. I still wasn't sure of all the things that one could do with a math degree. But I knew I loved to travel and I wanted to do something good for the world. So I ended up applying to join the Peace Corps, and I ended up accepted, and I studied, or rather I taught math to high school students in rural Kenya. So I'm just going to go forward a little bit to show some pictures. This is me from 2009 to 2011 in very rural Kenya with a group of my students standing in front of my school. So this is the high school that I taught at. I taught mostly Form 1, which is the equivalent of freshman in high school. And this picture on the bottom right was the classroom I taught in. So it was very bare, just the basics. The school didn't have electricity or running water. Neither did I at my home. So that is where I spent some time working with students, teaching them math and life skills. So I'll go back here. So at the end of my time in the Peace Corps, I still wasn't sure what I wanted to do. And so like many others facing this kind of uncertainty, I decided to go to graduate school to get my PhD in applied math, hoping that it would prepare me to somehow save the world using math. I have always been kind of an idealist. Math continued to be pretty hard for me, but in graduate school at Case Western, I really kind of hit my stride and started to excel. It never came naturally to me, but I loved the challenge and the exhilaration that came with solving problems. And I loved collaborating with my classmates and growing in my understanding of the wonders of mathematics. So when I graduated with my PhD in 2016, I still had no idea what I wanted to do. You may be getting a theme here. After 9 years of studying math, both as an undergraduate and in grad school, I still no one had really told me everything I could do with a degree in math except teach. So I went to Emory University, where I was a visiting assistant professor for a while. I found that while I loved teaching students, the other aspects of academic life were not for me. And while I was at Emory, I learned about the AAAS, or the American Association for the Advancement of Science and Technology Policy Fellowship. I learned about the fellowship through my membership in the American Mathematical Society. And in reading about the fellowship, I discovered that it allowed scientists and mathematicians to work in government, in Congress, or in the executive branch to use their technical skills to help solve real-world problems. I was very intrigued by this. So I applied and I was accepted, and I spent a year working in Congress for Senator Amy Klobuchar of Minnesota. So I'll just, this was my cohort on the Hill. Well, this was the cohort of fellows. So some of these people ended up in the executive branch, some in Congress. So this little orange circle is my head. So that is me. And I worked for this person, Senator Amy Klobuchar. She ran for president a couple years ago, so you may recognize her. Doing all kinds of things, working on her education portfolio. I worked on this piece of legislation called the Career and Technical Education Research and Outreach Act of 2018, which was signed into law as part of a larger package. And part of what was important about this time I spent on the Hill is less than 3% of Congress has background in math and science. And that's pretty stunning considering, you know, this day and age, all of the things that lawmakers have to do that involve science and math and cybersecurity and infectious disease. There's a lot of very important things that we, as you know, people interested in science and math, can help support our lawmakers in doing. So back to my timeline here. As a AAAS fellow, I got to meet with other people like me, people in STEM fields working for the government, and it really opened my eyes to the whole universe of things I could do with my degree. I finally got the answer to the question I had been seeking for years, the question of what I could do with my math degree, and the answer was amazing. It was anything I wanted. And so I now work for the US Department of State in the Bureau of Conflict and Stabilization Operations. And my bureau's mission is to anticipate, prevent, and respond to conflict around the world. And I work in the Office of Advanced Analytics. And our role is to use quantitative methods like mathematical tools to support the Bureau's mission. And I lead a team of analysts, people with STEM degrees or political science degrees, who use math, statistics, and data science to better understand conflict in different parts of the world and help policymakers make better decisions about US foreign policy. And this is a Haitian flag here because last year I was in Haiti as part of my job for 7 months. Let me just go forward a little bit. This is a little bit of some examples of what I do. These are open source, so not something that I produced, but I myself and my team use data to understand what conflict looks like around the world. So this shows conflict events all over South America. And then on the right, we see a graph of protests and violent demonstrations in Bolivia. So all of this with the goal of making the world more safe and our country more safe. And I just have a couple of examples that I will not go into detail on, but just kind of showing the range of ways that you can use data and mathematics to understand real world problems and solve problems that affect our world. So in my job, I get to work with amazingly smart people and try to make the world a better place using my math skills to do something I never knew you could do with math. So I've been talking for too long, so just to say a couple things in conclusion, I have learned a lot on this journey so far, and I'll share a couple of those with you. First, even if you don't get an answer right, doesn't mean you aren't good at something. It doesn't mean you can't do it. Math is hard. Getting wrong answers helps us learn and grow. And I have gotten a lot of wrong answers in my career. And it is important for your teachers and parents to believe in you, but believing in yourself is the most important of all. You can do anything you set your mind to. Also, there are so many amazing things you can do with math. Even if you decide not to become a mathematician, studying math will teach you how to solve all kinds of problems. It will make your life richer and more beautiful. It will open doors you never knew existed. And lastly, follow your heart. Even if you aren't sure about the destination, doing what you love will always lead you to a good place. And that is all I wanted to share. I'm happy to answer questions later. I really appreciate the opportunity to speak with you all. And thank you. very much. I will unshare my screen.
Thank you so much, Dr. Callahan. That was a really interesting presentation. And now we're going to be moving on to our Q&A session. So if you have any questions for Dr. Callahan, then feel free to put them in the chat and I'll read them out and ask. But in the meantime, here are some questions that we have for you. So the first question is, what inspired you to pursue the career path you took? Was there a specific moment, class, or experience that led you here?
Is that a question for me?
Oh yeah, that was a question for you.
Yeah, I think I touched on that a bit. It was definitely that I think I can I owe it all to that one teacher that I had, which really just like in the times that I have been a teacher since, in previous years, as a grad student, when I was teaching in Kenya, I always think about that teacher, that math teacher I had as a senior in high school, who really made me love math, because it's really just, it takes one person to make you either love a subject or hate it. And for math, it's especially important how you present it. So I think it's just that one professor. I don't even know her name anymore. It was many years ago, but she inspired me, and the rest is history.
Thank you. So our next question is, we rarely hear about mathematicians working in fields like foreign policy. So are there any other sectors of government or public policy that you think a career in mathematics is relevant to?
Yes, absolutely. I mean, I think really anything that you can think of that uses data or problem solving, you could use mathematics to help support the mission of those organizations. I think when I was applying to be a science policy fellow in the executive branch, I had interviews in all different agencies, so including the Department of Energy, the Department of Defense, USAID, so the International Development Organization. And so they all needed people who are comfortable with math and with numbers. And so I could have ended up in any one of those places. And I think the same is true for anyone who might be interested in pursuing a math career in government. And then, of course, there's a whole universe of possibilities in the private sector, which I don't know as much about. But really anything, part of what I think I would advise is, over the course of your math studies, like talk to people and find out what's out there, because as my kind of career story indicates, I went for many years without knowing what I could do, without really understanding the real world applications of what I was learning. And when I figured it out, it was really eye-opening.
That sounds great. And we have one more question. So what advice do you have for young women interested in math, foreign policy, or just male-dominated fields in general?
Oh, that's a really good question. I think just know your worth, and never, I think, like, I don't know if folks in the room have heard about imposter syndrome, but that's something that I've had a lot of. It's just like the belief that you aren't qualified to do something, or that you aren't suited for something, and you feel like you don't deserve to be where you've gotten, like you're not qualified, and everyone like knows you're an imposter. And I think that's it's more common for women, because we tend to be often more critical of our own abilities. But just know that that's very common. But it doesn't actually mean that you're less or that you can do less. It's just society's internalized perspectives from society that maybe we can't do something as well. And you just, silence that voice, find other women in STEM fields and male dominated fields and talk to them, learn about all of the amazing things they do and realize that you do belong. And just never doubt that you deserve to be in the room, to be at the table. And yeah, that's my advice.
Yeah, thank you so much. That's really great advice. And it looks like we do have a question in the chat. So, do you think your career would have been different if you were made aware of everything possible for you to do?
That is a really amazing question. I do think it would be very different. I think I probably would have, maybe I would have had in mind exactly what I wanted to do after graduating. And, I would have probably ended up somewhere really different. I don't think I would have ended up in foreign policy. I probably would have ended up in maybe a career outside, a mathematical career, doing something a little more traditional, maybe working in as a data scientist or something. So yeah, I think I wish I had known early, I guess. Part of why I like to talk to students is because I want to make students aware of all of the cool things you can do. But if I had known, I probably wouldn't be where I am, because I had to take the kind of rambling journey to end up here. So yeah, I don't begrudge it, the journey that I've been on. So, but I do think it would have been really different, although I can't predict where I would be now, but it's a good question. Thank you.
Thank you so much, Dr. Callahan. And I think that concludes our Q&A session. So everyone please join me in thanking Dr. Callahan for her wonderful presentation and also the wonderful advice and answers she gave us. And now we'll be moving on to, I believe, the quizzes.
Yeah, I also do want to say another sentence. Thank you so much, Dr. Callahan, for joining us. And your journey was definitely very unique, but just having those defining moments and experiences can definitely change the trajectory of many of our lives. And it is very inspiring to hear yours, and especially in a field that is not very common. That is also very inspiring. But everyone, please join me in applauding Dr. Callahan. We really do appreciate it. Okay, and then I will hand it off to Ira to do the quizzes. All right, hello again, everyone. So we're going to move into a little bit of an interactive portion of our ceremony today, and we're actually going to be doing a quizzes. So if you all know what quizzes is, it's like Kahoot, but it's slightly different. So we're excited. So get competitive. We're going to have a leaderboard, and there are prizes involved. So on your screen, you're going to see a link to join. So you can go ahead and type that link into your browser. It should work on a phone or a laptop, and you can click our join code, which is 744688. And we are going to be answering some questions about women in STEM and hopefully learning a lot. We're going to give everyone, I think, 2 minutes just to get started and enter our code in. So go ahead and take your time, but go ahead and put in your name as your username, and then we will start the competition. All right, so we're at 32 people, so just a few more people need to join. Our code again is 744688, and you can get to quizzes by typing into your browser joinmyquiz.com. I think we'll start again in about just 1 minute. 43, so almost everyone is on. I would highly recommend you join. We are going to have a prize for our top winner, so definitely get on our quizzes. Also, you can join during the quizzes, so we'll go ahead and start, and you can always hop on after a question or two whenever you can get your code in. All right, it's time for our first question. And our first question is, who was the first woman to go to space? Okay, awesome. Look at all the responses coming in so quickly. Just a few seconds left, about 5 seconds, so go ahead and get your answers in there, everyone. Awesome, let's take a look at our leaderboard. Okay, we have Sylvia in the lead with 910 points. Let's try to beat Sylvia out this next question. Good job, everyone. In 1882, Ferdinand von Lindemann discovered which mathematical constant? Oh wow, y'all know this very well. Look at that. We're about halfway in. Go ahead and get your guesses in. That's about 1 second left. Let's see if Sylvia has kept her lead or not. Oh, she has been unseated by Cecilia. Okay, awesome, y'all. Let's just keep going and keep this competition up. Our third question is, Lamar was an Austrian-American actress and inventor who pioneered technology that would one day form the basis of which of the following? This one seems to be a little tougher. You guys aren't answering as quickly. All right, you guys, we have about 10 seconds left, so go ahead and get your best guess in. All right, now let's see who's in the lead. Has Cecilia remained, or do we have a new first place? Okay, competition is intense. Now Elaine is in first place with 2,500 points. So we're going on to our next question, which is, how many colors are needed on a map to ensure that no two colors share the same border? Two of you guys answered in like 1 second. Very impressive. All right, guys, again, just about 10 seconds left. So go ahead and get those best guesses in. All right, let's see who's, Elaine is still in the lead. Good job, Elaine. Elaine has maintained her edge. She's at 3,300 points. And on to our next question. The programming language Ada is named after who? All right, you guys, we have just about 10 seconds left, so go ahead and put in your answer. So let's see who's in the lead. Elaine is still in the lead, over 100 points on second place. So good job, Elaine. Let's try to unseat her in this next question. Which of the following numbers is irrational but not transcendental? All right, you guys, there's about 2 seconds left. And now let's see who's in the lead. Wow, okay, so Cecilia is making a comeback, but Elaine is still solidly in the lead. You guys have to try a little bit harder. We have to get out of first place. On to our next question, which is, who was the NASA human computer that recently passed away at the age of 101, who was also the subject of the hit movie Figures? Just about 5 seconds left, so go ahead and get those guesses in. Wow, I'm very proud. Looks like Elaine is still in the lead, but Grace and Valerie are close behind. We're on our 8th question, you guys, so definitely time to speed it up as the competition is getting intense. And our question is, what is the only temperature that is the same in Celsius and Fahrenheit? There's about 10 seconds left, so definitely keep putting those answers in. Time is up. Let's see who's on the leaderboard now. Looks like Elaine has retained her streak, and this is her 6th-time streak for first place. And so we're going to go on to the next question, which is Marie Curie, the first woman to win a Nobel Peace Prize, won the prize for which of the following scientific discoveries? All right, we're counting down. We're just about 5 seconds left. We're going to end out our 8th question of the day for our 9th question of the day. Elaine is still in the lead. She has about 900 points on 2nd place, Valerie. On to our next question. What is the word that is defined as 1 times 10 to the 10th power to the 100th power? There's about 3 questions left and about 10 seconds left for this question. It looks like Elaine is still in the lead. She has about 1,000 points on her opponent Grace, but I think Grace and Valerie are catching up. On to our 11th question today, which is, what is the leaky pipeline? So this is a little bit different from some of our previous math questions, but I think y'all will be able to figure it out. You might have experienced this phenomenon yourself or seen it at school, maybe with a family member or a close friend. All right, awesome. We just have about 5 seconds left, so go ahead and get those guesses in for what is a leaky pipeline. This question, Elaine is still in the lead, but we still have Grace and Jasmine closely behind her. Good job, you guys, for your guesses. Second to last question, which is how many of the circles in this picture have dots in them? So be sure to look carefully on your screen. We have a little bit longer time for this question. Just about 20 seconds left, so go ahead and carefully add our picture and go ahead and put your answer in. That's right, you guys, 10 seconds left. Let's see what this question is the leaderboard. Okay, so we see Patricia has unseated Jasmine as third place, but we're very close together. And our last question, our 13th question of the day, which is how many months have 28 days? All right, just about 20 seconds left. Last question, you guys. We have prizes attached to this, so definitely get your answers in for a chance for a prize. We're gonna be wrapping up our quizz's last question in about 5 seconds. Time is up, and now we're gonna view our final leaderboard. So it looks like we are on the last question. About 24 of you guys did not get this question right, but that's okay. And so now we're gonna look at our final leaderboard. Congratulations to third place. I don't know who put their name as math, but math, good job. Second place, we have Jasmine Wang, so congratulations, Jasmine. And first place, Elaine Gu, who kept a streak for I think about 10 questions at first place. So big congratulations to everyone. I hope you guys learned something from this quizzes. And for our first place winner, we have a very special prize for you. So keep an eye on your email for that prize. So next, we're going to be transitioning into our second esteemed speaker of the day, who is Professor Wheeler. And so I'm going to hand it off to my team member to introduce Professor Wheeler and get us started.
Okay, hi everyone. So now we will be introducing our second guest speaker, Professor Ashley Wheeler. Professor Ashley Wheeler is a postdoc and assistant professor of mathematics at Georgia Tech. She received her PhD in 2014 from the University of Michigan, and she has since worked at the University of Arkansas, James Madison University, Mount Holyoke College, and Georgia Tech. Professor Wheeler's areas of expertise are in commutative algebra and the study of solutions to systems of polynomial equations. Please join me in welcoming our second guest speaker, Professor Ashley Wheeler.
Hi, can I go ahead and share my screen?
Yes, let me transfer the host privileges to you. Just 1 second. It seems like for some reason I can't make you host. Not sure why it doesn't show up.
I wonder if I can share it anyway.
Oh,
All right, it says that I'm sharing it.
perfect. Yeah, we can see it.
Okay, great. All right, so I'm gonna keep this kind of short. I just want to give an idea of what I do as a mathematician, and then I'll try to save a lot of time for questions at the end. So thank you to the organizers of this math competition, and thank you very much for inviting me to speak. Since fall of 2021, I've been at Georgia Tech, and at Georgia Tech, I've been doing research and teaching linear algebra and commutative algebra. So this picture is Skiles Classroom Building. This is the math building at Georgia Tech. So what's linear algebra? That's one of the courses I was teaching. It's the study of solving systems of linear equations. So here's an example. This is a system of 3 equations. There are 3 variables, x, y, and z. And what makes the system linear is that there are no exponents on the variables. Like you don't see x squared or y squared. And also the variables are not being multiplied together. So you don't see like xy or xyz. Each variable is either by itself or it has a number in front of it called a coefficient. So it turns out that systems of equations like this, all the information about the equations is really in the coefficients of the system of equations. And so if you feed this information into a computer, the computer can solve the system of equations for X, Y, and Z pretty easily. So here's a picture of the same system of equations. The coefficients are in the matrix. So if you notice this first equation, we don't have a coefficient in front of X, we just have X. And so that's why there's a 1 here. So there's a 1 in front of Y, a 1 in front of Z, and then the answer is 1. And similarly for these other two systems of equations, just the coefficients of the equation goes into the matrix. So the other course I taught, or I teach at Georgia Tech, is commutative algebra, and that's actually my specialty. That's what I got my PhD in. Commutative algebra is like linear algebra, except instead of solving linear equations, you're solving polynomial systems of equations. So here's an example. This time, there are 3 variables again, X, Y, and Z, but this time you can have exponents on the variable. So here's an X squared and a Y cubed, and here's an X squared Y. So you can have the variables being multiplied by each other. You also notice that I only have 2 equations in the system because having a lot of equations in the system when they're polynomial equations makes things really complicated. Whereas in a linear system of equations, if you have, there's a fact that says that if you have the same number of equations as you do variables, then most likely there's a unique solution to the system of equations. That's not necessarily true with a system of polynomial equations. So computers can't solve polynomial equations very well. There is a software that I use in my work called Macaulay 2, and what it really boils down to, whereas linear algebra uses matrices to solve systems of linear equations, in commutative algebra, we use what's called rings and ideals. And these are abstract algebra objects that we study to try to solve systems of polynomial equations. So what about research? I said that at Georgia Tech, I teach and I do research. So I told you about what I teach. Research, a lot of people don't know what math research is, but it's just writing proofs. It turns out that not all math has been discovered yet. There's still a lot more. And so I spend my time just staring at problems that nobody solved before and trying to come up with solutions and proofs that I can publish in a paper. Since grad school, and by the way, to get a PhD in math, you have to prove something that's never been proved before. So I did that in my thesis. My main area of research has been with what's called principal minor ideals. But over the years, it's also dipped into subfields of commutative algebra like combinatorics and tropical geometry. Tropical geometry is particularly interesting, but I've only gotten into it a little bit with one particular project I did recently. So about principal minor ideals, there's a very rich, well-studied area of research within commutative algebra called the study of determinantal ideals. And the idea is that you start with a matrix, except instead of numbers in the matrix, you have your variables. And then if you know what a minor of a matrix is, or what a determinant of a matrix is, if you take the determinant or one of the minors, you get a polynomial in those variables that are in the matrix. And then when you set it equal to 0, you get an equation. So my main area of study, principal minor ideals, falls into this category of determinantal ideals. All right, so that's all I really wanted to say. I just wanted to give you an idea of what I do and what it's like being a mathematician. I do have some question prompts, but I think I see something in the chat. Oh, I see. Does that mean everyone who has a PhD in math has basically made a new discovery in math? Yes. Yes, that's absolutely true. Like, to get a PhD, you have to discover something new. Great. So Yeah, some prompts that I had that I thought you might want to know. Have you taught any other courses besides algebra? What is your favorite? Um, well, my specialty is in algebra, and in pure math, there are three main areas. There's geometry and topology, algebra, and analysis, which is calculus, except when you get to a certain level, they stop calling calculus calculus and they call it analysis. So my specialty is in algebra, and that's what I like to teach. But I have taught I've taught calculus, all levels of calculus at the university level, so Calc 1 through Calc 3, and then some schools call it Calc 4, some schools call it differential equations. I've taught that course before. I've taught another abstract algebra course called group theory. So groups are another abstract algebra object that don't come up very much in my work, but I have taught a course in it. But I have to say that my favorite course to teach is probably linear algebra, just because it's so well studied, and the theorems in linear algebra are very interesting, but the proofs are also intuitive. And this is something I like about algebra in general, as opposed to, for example, analysis. I've read proofs and analysis, and in my opinion, they're not very beautiful. They're usually very messy, whereas I think proofs in algebra are kind of concise and simple. I see something else in the chat. What did you prove? How long does it usually take you to prove something? Is there a specific field you usually research? It depends. So what did I prove? In my PhD thesis, I studied ideals generated by principal minors. So I kind of touched briefly on ideals. They're basically used to study the equations themselves. So I proved some things about the ideals you get from principal minors. How long does it usually take you to prove something? Well, my thesis, everything in my thesis, it took about 9 or 10 months to prove, but there are some other projects where it's taken longer. There was one question in my thesis that I was never able to answer until 6 years later. I was able to prove it. And it went into a paper that got published. I also had this other project that was in tropical geometry, and this was a collaboration with 6 other women. We actually met at a workshop for women in commutative algebra, and it took us 2 years to get a paper from that workshop. Part of it was because it was during the pandemic, and part of it was because my co-authors lived in different countries around the world, and so we were meeting through Zoom for 2 years. Let's see, one of my co-authors is in UK, one of them is in Slovenia, one of them was in Iran, but now she's in Belgium. One of them was in Canada. So it depends on what you're proving, how long it takes. Oh, I thought I heard someone say something. Was there another question? All right, well, here's another prompt. How did you decide you wanted to be a mathematician? That's an interesting question, because ever since I was a kid, math has always been my best subject. But I think for a long time, I kind of saw it as like a pesky little brother. Like I do have a little brother, and even though I love him very much, he's kind of always there, whether or not I want him around. And that was kind of how I felt about math growing up. I felt like it was always there, and I did really well in math, but it wasn't necessarily something I wanted to do. But what changed my mind was when I was in college, I was a physics major, because originally I wanted to be a cosmologist like Stephen Hawking. And I declared a math major to supplement the physics major. But then I noticed that my grades in my math courses were better than my grades in my physics courses. So I just, I kind of figured, well, I must be better at math and I probably like it more than I like physics. So I applied for grad school in math and got in. And that's how I kind of like found myself in that field. I see questions in the chat. Where do you find what to prove? That comes from going to seminars and going to conferences. Every place I've worked and my grad school had algebra seminars where speakers from around the country would visit and give a talk about their work. And it's a really good networking opportunity. You can ask people questions about their work, and if you're really interested in what they're doing, that leads to collaborations. Most of the papers I've published have been collaborations, except for my first two, which were based on my thesis. What do you do when you just can't figure out the problem? Do you ever just give up? It depends. Like there was one problem I was working on when I first got to Georgia Tech, and it was a problem from my thesis that I had never answered. And I thought, like I had an idea for a theorem that I thought was true. And I thought, since I had already proved it in a specific case, I thought that proving it in the general case would be easy. And so I even kind of saved this problem as a possible problem that I could give to a student. I thought it would be pretty straightforward to solve. But then I started looking at the problem myself and trying to prove this theorem by myself. And it turned out to be really, really hard. I spent like months just focused on this one problem. And eventually I got as far as I think I can go. And I decided like I could keep pursuing this, but I really there's a lot of pressure to publish in academia, and I thought this isn't going to be publishable for a while. I really need more time to think about this. So unfortunately, I ended up thinking about something else. But the good news is that there are always problems to think about. So like if you're doing a problem and it turns out to be hard, it's okay to just put it on the back burner. Like I said, there was a problem for my thesis that it took me 6 years to prove. And I just kept it on the back burner until one day, 6 years later, I had an idea of how to prove it. And then I proved it like in an afternoon sitting on my back porch. Let's see. Oh, there's another question. How do you start on a problem and how do you prove it on paper? Is it just a straight line of thought? No, it's not. Like, usually when I try to prove something, I have an idea of how to prove it. And it's usually something that I think is true. So if you have a theorem that you think is true, you usually have an idea of how to prove it because you want to justify why you think it's true. But then like when proving it becomes challenging, like you have to try like different approaches and different techniques. So when I was trying to prove that one theorem, I had like lots and lots of scratch paper everywhere at my house because I was trying like different things and it wouldn't work. So I would throw the paper away and try something else. I have one more question, but I think I'm out of time. So if I'm out of time, well, the last question is, did I ever compete in math competitions and did I enjoy it? And the answer is yes, I did. When I was in grade school and when I was in college. One time when I was in college, I competed because the prize was money and I wanted money to pay my rent. And so I competed in the math competition and won and used the money to pay my rent. but yeah, math competitions are good. And I think it's good that you all competed in this one, and I think you should keep it up. But I'll go ahead and stop now. I think we've run out of time.
Yeah, thank you so much, Professor Bueller. Hearing about the things about your journey in math and then the things that you teach. I actually am in a linear algebra class right now, and it's definitely a lot, but it's very fun, but it's definitely a lot. But it's very interesting. I think I have a lot of respect for mathematicians and people who teach math, especially at the university level. And it's just very inspiring to hear about your experiences. So everyone, please join me in thanking Professor Wheeler. We really appreciate you joining us today, this Sunday afternoon. But yeah, I think we're going to move on to the most anticipated part of our award ceremony, which is the announcement of our winners. So I think it is going to be Rika who announces 6th grade winners.
Okay, so first of all, I wanted to congratulate all of you for participating in this competition. You all did really well, and this competition has been a lot more competitive than it was in previous years. So yeah, all of you did great. And now for our top 6 for 6th grade and below. So in 6th place, we have Josephine Wang. In 5th place, we have Grace Leong. In 4th place, we have Yuhan Chi. In 3rd place, we have Danica Wang. 2nd place, we have Emily Wang. And our top scorer in 6th grade and below is Elaine Gu. Congratulations to all of you.
And now I think Emily will announce 7th grade winners.
So this is the 7th grade tops. In 6th grade and 6th place, we have Emma Bowman. In 5th place, we have Laura Wayne. In 6th, we have Chloe Ma. In 5th place, we have Alice Yin. In 2nd place, we have Yunong Wu, and our top scorer in 7th grade is Selena. Congrats to these top scores. So now pass it on to Anna to announce the 8th grade top scores.
Okay, so sixth place for top 8 is Ella Yu. 5th place for 8th grade is Jamie Jung. 4th place is Avery Young. 3rd place is Patricia Ma. 2nd place is Valerie Hu, and our top scorer for 8th grade is Caroline Huang. Congratulations to everyone who was in top 6 for all 3 categories.
Next, we'll be announcing everyone who made it to an honor roll. And before we do that, we'll announce the current statistics for the competition. So the most missed problem was question 15, and the answer to that was actually E. None of the answer choices were. The average score for the contest was 16.2, and the median was 15. And the highest score, we had one perfect score, who was Selena. Yeah, next we'll announce the honor roll. So the honor roll cutoff for this contest was 16 out of 25, and it was the top half of the contestants. And next we'll show the list of people who made it. So I want to take a moment to recognize everyone here who made it to honor roll. Congratulations, and also congratulations to everyone for participating in this contest. It's not easy to do a contest this long on a Sunday, but I'm glad you all joined. Yeah, thank you all.
Congratulations to everyone. So this is our upcoming MIG event. So today at 7 p.m. Central Time, Professor Koshin is going to talk about how to pursue the math competition in the era of ChatGPT. And then this QR code is basically the registration link, and you must register each one. If you register, the link to the Zoom meeting. Right, everyone, so make sure to go ahead and scan that QR code to register for the
Dr. Costello, and next we're gonna move on to something very exciting, which is our 2023 t-shirts. You can see this beautiful design we have in the back. It's actually an equation, so you guys can go ahead and maybe even enter it into Desmos and see what you get. It's this beautiful flower. So these t-shirts are going to be $20, including shipping. So the way you can order is by either scanning this QR code or typing in this bit.ly that you can see on your screen, which is bit.ly/MIG t-shirt orders 2023. And basically all payment information will be on the Google Forms. Be sure to definitely email us if you have any questions or concerns. And we are a nonprofit organization, so any money that we make from these t-shirts will go towards paying for this year's competition and next year's competition. So we hope that you can support us today.
So, I have something very exciting to announce. So this year we have a new Discord server, and here's the QR code for the join link. I believe the invite will also be sent in the chat by Rika. So if you guys want to click on that and join, that'd be great. Yeah. Oh, yeah. So the exam questions will also be posted on there later. And you guys can discuss that after we post it. So yeah.
Okay, and then last but not least, thank you to our sponsor, which is Connections Tutoring Center. And also thank you to the University of Memphis, which is the space that we're using right now, and Dr. Ivy for allowing us to use this auditorium in the engineering building, and also our helpers, Olivia, Sophie, and Samantha, who are over there, sorry, who helped us set up today. But very big thank you to the University of Memphis. And yeah, that is the conclusion of our award ceremony. Thank you guys for coming. We are so excited to see you all. And all the recap, this PowerPoint slides and the winners, results, and our links will all be sent out in an email, a conclusion email to everyone, either today or tomorrow. So yeah, we hope you do support us with the teachers and also join our community through our Discord server. And this award ceremony should be posted on our YouTube channel, which is Math Invitational for Girls, later this week. But thank you so much. Thank you again for joining. We hope to see you next year if you are still in middle school. And if you are an 8th grader, we wish you best of luck in your high school journey. But yeah, and also thank you to our guest speakers again. And hopefully we will see you guys next year.